Okay, now watch now. Now this is one of the oxidation states. That is oxidation calculation. Now with the use of what valencies. So that is it. So watch now. Here they said, what is the oxidation number of carbon in the following what compound stroke what radicals. Now the first one said sodium, the sodium trioxocarbonate what, I don't know. So let's solve it now. Now we have what solution. Am I making sense? That is the first part. So this is the first one. The first one here says Na2CO3. Now let's check. Now I said before that if we don't use the valencies, the atomic masses in chemistry, you might not be able to know some of the parts or calculations there. Am I making sense? So if you knowing this thing now, knowing this oxidation state, you have to be able to know the valencies of each of the what compound elements. So that's it. So watch now. Now watch. What is the valency of sodium now? The valency of sodium here is what? 1. So, and this oxidation state, one of the rules said that the sum of all the what individual elements in the given compound must be equal to what? 0. That is the sum. Now, watch. Here is equals to. Now, because we have 2 as the what? The atom there. Now, but the charge, which is the valency of the sodium is +1. So we have 2 times +1, which is what? 2. So plus, we are looking for the carbon because we are asked to find the oxidation number of this carbon. So we are asked to find the oxidation number of the what? The carbon there in the what? In the compound. So we make C. We use X as a variable to replace what this C we are making use of, we are looking for. So plus what? Now, what is the valency of oxygen? -2. So we are going to know it now. Now, -2 times 3 is what? -6 now. Now we have -6. It's equals to 0. That is one of the rules there. Not making sense now. So watch now. So you calculating this thing now, it will now be 2 plus x. Now, minus times plus is what? -6 is equal to what? 0. So x 2 minus 6 is what? -4 is equal to what? 0. Am I making sense now? So x now, crossing the sign of this equation now is +4. Now, mind you that whenever we are dealing with oxidation state, mind you that we have to make use of the positive. We don't just say 4. We must pronounce that word +4, because in chemistry, the oxidation state there, you must pronounce whether it's negative or positive. We have -4 or positive what? 4. So either the -4, we can't just say 4. But in normal mathematics, even though we remove this plus sign, it is still +4. But in chemistry, we don't use this. We apply the principle there, which is +4. So the next one, now, rather than this one, let's move on with this calcium trioxocarbonate 4. Alright, so let's move on to this number 2 now. Now, this B said calcium that is CaCO3. So we have now calculated the first one. We got 4. That's +4 there. So let's calculate this one. Now, what is the valency of calcium there, which is +2? Now, +2, which is equal to what? +2. Now, +2 plus what? Carbon. We are making use of carbon. Let's use Y in this one. Now, 3 times -2 is what? +-6 is equal to what? 0. So watch now. Now, 2 plus y minus what? 6 is equal to what? 0. So y 2 minus 6 is equal to -4 is equal to 0. So y now is equal to what? +4. So we all believe that the first one here is disodium trioxocarbonate 4. The second one is also calcium trioxocarbonate 4. So the carbonate family that belongs to that entity there is called or which is the oxidation state or what number there. So that is it. Now jot down this second part. Let's move on with the number 3 question. That is C question. Alright, this is the third part. We want to move on to the third part. Now this third part now is trying to tell us is a what? CO3 negative 1. Now this is not a compound now. Now watch. Because they say what is the oxidation number of the carbon in the following what? Either the compound or the what? The radical there. So here, this is the radical. And the rules of naming the oxidation state in the radicals is not something in the compound. The compound must be equal to 0. The sum of all the individual elements there must be equal to what? 0. But in radicals, it's not what? Like that. In radicals, the sum of all the individual elements must be equal to the charge at the word superscript. Now, what is the charge of the superscript, which is -1? Because here we have -1, but the 1 is what? Invisible. Now, here we have what is the what? We are looking for the C, which is the carbon there. So watch now. Now this is X. We make use of X. Now plus what is the charge, the valency of the oxygen there, which is what? -2 times 3, the same -6 is equal to what? -1. It will not be that 0 because we are making use of the radical there. So these rules will give us the total number of the charge at the what? Superscript there. So that is it. So let's solve now. Now the X now, but we are looking for the X. Now minus times plus is -6 is equal to what? -1. Now X is equal to -1 because of the mathematical equation. Whenever you see this kind of equation like this, we what? We transcript by what? Changing the sign of the equation. That is plus 6. Now X is equal to what? -6 plus 6. Sorry, -1 plus 6 is what? Plus 5. So watch, let's pronounce it now. Now this is trioxocarbonate 5 ion. It's not a compound. This one is a compound. This is calcium triosocarbonate 4 what? Compound. But this one now is trioxocarbonate 4 ion. So these are ion because you have a charge there. What is an ion? Ion is 2 or what? More what? Rather atoms with a charge at the what? Superscript. Either 1, either 2. So just like you have sodium plus. So this sodium what? Ion positive. But this one now is a radical. What makes it a radical is due to the what? The combination of what? The carbon and the oxygen there with a charge at the what? Superscript. So that is it. Now jot it down. Let's solve the last part being the D there. So this is last part now. Then the last part is CO what? 3 negative 2. So the same thing we did in the other third one. So this is X. We are looking for the C there. So 3 times -2, which is what? -6 there, is equal to what? Because of the charge, number of the superscript, number of the what? Charge at the what? Superscript, -2. Now X here, -6 is equal to -2. Now X is equal to -2 plus what? 6. X is equal to what? Plus 4. Now the other one is 4. Sorry, 5. But in the state of some of the reactions, they make use of the 4, a triosocarbonate 4 family. Why? Something like you want to times sodium now, something like sodium now, +1 like this, then and the CO3 -2. When we cross multiply this now, we have sodium 2, then CO what? CO what? That is CO CO3. That is when this one multiply with this one. Now this one will now form this one, which is CO3 like this. So that is sodium triosocarbonate 4. So we make use of the triosocarbonate 4 family, which is this one. So this one now is more stable than the third one, which is triosocarbonate 5. So but we make use of this one in the reactions of some of the compounds. So thank you and God bless. If you like our video, if you want to advance more, you comment in the comment box, because it helps us. It really helps us to what, to advance more on our knowledge. So please try to comment, try to subscribe, share to other people, because what we are doing here is really good for some people that did not know some of the science. Now, we are not doing only chemistry, we are doing mostly the what, the subject, but basically science subject. We can do what, mathematics, we can do computer science, we can do physics, we can also do electrical, electronics, what, installation. So, but we can also do biology and other things. So we are here, we are basically here for what, science subjects, all the sciences in life. So if you have any question, anyone you want me to teach in the what, in the group, I will have to what, teach it. Just try to mention the topic, let's solve it, let's get it done. Thank you and God bless. Have a wonderful day.